Hey everyone, it's Jake Clark, John Schneider, Eric Faldy, and our full-time employee, Todd Atchison, on the Fargo 3D Printing Podcast today. So we're going to cover a bunch of different things. First, we got an exciting announcement about the Z18. Then I'm going to go into some grave detail on my theory of heat creep. I have diagrams and pictures. So if you're listening on the podcast... He's
not kidding.
If you're listening to the podcast today... check out our YouTube channel for the video part of it because it'll make a lot more sense because it's probably about 15 minutes that I'm not going to make any sense.
It's going to be pointing at things and you won't see nothing.
Yes. So let's start out with and then the rest of it, I don't know what we're doing.
Typical.
Just figure it out.
So the first thing is Z18. So we are now, Fargo 3D Printing is now standing behind the MakerBot Z18 with its smart extruder. We've had some really great prints off the firmware. So it's kind of a big deal. We stepped away from selling the MakerBot line entirely for about...
the 5th gen line.
5th gen line,
the 2X we've been behind.
But how long? It's been about 4, 5, 6 months?
6 months. Yeah, I'd say about 6 months since we quit selling them because there were too many problems with the smart extruder. The firmware wasn't there. The software wasn't there. There is one thing that we're still trying to get figured out with the software, but from the hardware point of view, we think that it's a solid machine now.
Yeah. So the Z18, for sure, we're standing behind. We've gotten some really great prints. We printed this. The surface finish is that of a Rep 2. The bottom's pretty damn good. It's all around. I mean, we've been working with this for the last 2-3 weeks. The latest firmware has greatly improved the surface finish.
That came out like this week?
Yes.
Last week.
Last week. And to be fair, I mean, when we had some of the first prints that we got off of the Z18 when we unboxed it, I mean, they were good. They weren't quite this good, but we had some pretty serious degrading of part quality. And what we found was that the part quality was degraded. We had a lot of waviness in it because of loose belt. Well, I was going to say loose belt, but there's only the one belt in there. There's a tensioner in there that we were able to adjust, and now it's actually at a normal, normal tension, and that cleaned stuff up quite a bit.
Yeah, I mean, we still had some waviness, but do that in conjunction with your firmware. Check your belts. When you take the lid off, there's 2 aluminum pieces with pulleys in them in the front of the machine, in the top, that you can take one out and loosen it up a little bit, pull it back, and tighten it, because otherwise, like John said, it improves your waviness, and it's just one of those things. Like if you look at a Rep 2, the Y-axis secondary, if that gets blown out, the belt gets loose, and then you get some really crappy prints. So all around, that's kind of the one thing that the 2 things is update your firmware, update MakerBot Desktop, so 3 things, and then the third thing is look at your belts and tighten your belts.
I know that our first print on there was awesome, and then the next few,
it was pretty good.
So do you think it was just like out of the factory, it was like fine, and then after it just needs like an adjustment right after you started, or? I
honestly don't know. One thing that I do know is that the PLA was crap.
Okay.
The white was garbage.
Yeah, okay.
And we're still having issues with the white.
And that's the official MakerBot white PLA filament. It's almost like it's melting. It's almost like you're printing it too hot, but that's the stock setting. So we haven't tried turning the temperature down yet. We've been focusing just on getting good quality prints using right now. We've been using MakerBot Red PLA for our stuff, and it's been turning out great. So what Jake's actually holding is something that we're doing to help improve print quality even more. So what this is a filament spool holder. This will mount up above the Z18. This is a short so what you do is you have one of these in each corner. It sits right on top of the Z18.
You can't have the top on, right?
Right. Yeah.
This is a visual podcast, everybody.
So imagine that this is just an extrusion piece. It's a 90-degree angle with a slot in the bottom so that it sits right on top. And then what I take is just a closet rod and have it sitting on top in just a little curved slot.
We'll get a photo of.
Yeah, we'll get a photo and put it up there.
Because this actually is how long in real life.
No, it's not. This is 9 inches.
How long in there is it?
What do you mean how long?
They're like
No,
They're like
those-
this
Twice
tall.
that height.
Oh, yeah. So this piece that I'm holding is 9 inches tall. The final pieces are 17 inches, 17 and a half inches tall. And that gets the spool up high enough so that when your extruder's moving from side to side, front to back, that it doesn't pull the filament off of the spool. So it's also a really good print on the Z18. Just what other printer can you do 17 inches vertical?
And right now we're hanging our filament off the side. So
Right,
if
and
you're
that's-
still printing inside and you're not getting good prints, switch to the side holder, then print these, and then switch to this.
Well, the reason for that is to try and reduce the amount of friction that the filament encounters from the spool to the extruder. Because when it's mounted in the tray in the bottom, we've been able to get good prints out of there, but we also don't want to
really.
take. Well, yeah, but think of all the other changes that we've made. You know,
Yeah.
with
You
the
haven't
firmware
tried it
coming,
still
we haven't
since-
tried it with
still.
we haven't tried it with the
Shit.
but we haven't tried it with the new firmware. We haven't tried it since we've tightened the belts from the bottom. It might work just fine in the bottom. We haven't tested it yet.
Don't do the bottom.
Well, I think that we should at least test it and give it a shot.
What do we put
Don't do it
in
at the
there,
bottom.
If not filament, we put like, is that like pizza storage now?
well that too, but I put actually
pizza.
a great place is your Totino's pizza. No, it's the
Yeah, it's
Maker
not-
Care card. That's a great place actually.
It's a
for
good
it.
spot.
You actually do need to keep that with it somewhere, so you have it somewhere to reference. Otherwise, if you lose it, you're screwed.
Or spare filament.
Yes.
Yeah, or spare filament.
That's not a bad idea.
I mean, the big thing is just reducing the friction, making the printer work as best you possibly can.
Yeah, because I mean, you can't see in this one, but in some of the past videos, you can see that all of our Rep 2s, they don't have the guide tubes; they're all overfed. So none of them use even the back spool holder, which doesn't even have a lot of friction to begin with.
Well, and in our case, when we were using the back spool holder, it got to be a giant pain to try and swap spools
yeah.
out. Well, because of the way that our printers are mounted, they're pretty much right up against the back wall. And the Z18, now when you have it mounted overhead, now you don't have to feed it through that guide or the guide tube.
Yeah, because the top is kind of a pain too, because what they have inside is they have a piece where the tube from the bottom comes up in, and then from the tube from the outside, so it's like a splicer, so it's 2 to 1. But when you push it up in here, evidently there's not a fillet in there or something to guide it in all nice. So then your filament will actually get caught on the lip of the tube, and then you're sitting there, why isn't this going through? Pull the tube off, run it out, run it through the tube. It's just kind of a pain in the ass. So overhead spool all the way. Do that. Don't do anything else. That's my advice. John differs a little bit.
Well, no, I think that that's the best way to do it, but that doesn't mean that you can't do it the other way.
Yeah.
Because we just don't know what kind of prints we'll get if we do it the other way. Because there's going to be that many places, I don't know, that they just don't know to do the overhead method.
Right.
That they might say, okay, well, they don't know to even try it on the side or know to try it on the top. So I think there's going to be customers that will be getting prints that are just fine having it mounted in the tray. Maybe not as good as if it's mounted overhead.
Yeah.
So the one problem that we are still running into with the Z18 is on thin wall pieces. It's in the slicing part of it. It's not anything wrong with the hardware.
Oh, yeah.
Where it actually, the tool path that it generates, it'll have a hole in the thin wall. And we're not entirely sure what's causing that yet, because it's not a problem with the Replicator 2 using the slicer. But what we know, it's not a hardware problem because we look at the actual G code. It has basically the G code, the
Print preview.
the print preview, where it'll visualize, okay, the path that the extruder is
Layer
going to
by
take.
layer.
And there are little chunks missing out in some parts of the wall.
Like an inch tall kind of chunk. Inch tall. Sorry. Just spit
Good to
on my
learn
rose.
yourself.
But an inch tall and maybe like quarter of an inch wide. That's just missing.
Is that a model that works otherwise?
I haven't tried it on like the Rep 2,
So I'm
but
just
I've
saying
noticed
maybe
quite
it's,
a bit.
Maybe it's like an inverted face because I've had that happen.
No, it's
done in
it's
Inventor
not
and
that.
I've exported
It's
it.
not that because it's parts. I mean, we're talking
This
parts
is
that
something,
we've.
something you made.
Yeah,
No,
I mean,
well, no.
even the calibration block, I brought that in.
Yeah.
And I brought that in, and the first line, so it would actually, it's really hard to explain
It's
this.
like
So,
glitchy code. It's just
Yeah.
dropping
if-
entire sections of.
yeah, if
And
I was
even-
going to print this as a solid block, what would happen is like one shell, it would actually miss for like the first quarter of an inch. It wouldn't even like throughout the whole length. It wouldn't actually extrude it. It's a hole.
It's just
in the
missing the
G-code.
whole thing.
Yeah. And this is something that we've seen even on MakerBot's their slicing torture test. Now, this is a file that MakerBot developed that we have successfully run on the Replicator 2 in the past. We've also ran it on the 5th gen. We've ran it on the Mini. And for
And
some,
the Z18.
yeah, and we don't know if it's just a new version of the MakerBot desktop is causing the issue, because I haven't tried running it again on a 5th gen. I haven't tried running it again on a Mini. It's just been on the Z18 that the problem is. So I think what's probably happened is MakerBot's tried to improve print quality in the slicer for the Z18, and somehow they introduced a bug. So we just need to figure out what the issue is, and it seems to be mainly on smaller, thinner parts. Like this part here, haven't had a problem with it because it's a thicker extrusion piece. It's probably, I think it's probably quarter inch thick in places, or almost half an inch thick in some places.
But the part I was trying to print was one wall thick. It was so thin. But yeah, I mean, otherwise, some of the thicker parts, the calibration block was weird. It was doing that weird. And I think I print previewed that. I'll have to double check.
But the nice thing is we know that that's a software issue, that it's something that can be fixed.
Yes.
I mean, the hardware issues that we were seeing before, those seem to have been pretty much cleared up.
Yes, they're gone, virtually. And printing reliable. I mean, the two of these together, what was that, like how long of a print?
16 hours?
I think 16 hours. Now, I printed it on the low quality setting, but two pieces that were over 17 inches tall, and printing that in 20 hours, I mean, you can't, or 16 hours.
I'm not
but
sure.
It's somewhere between that.
For $6,500?
Yeah.
So $8,000 with the warranty, you can't beat that.
And the other nice thing is that the filament, when it runs out of filament, the filament detection actually works. And so I've printed a few pieces now where I was partway through a spool and ended up using more material than I thought it was going to. So it happened on that 16-hour print. It got about 12 hours into it, and then it ran out of material. So it stopped the print, unloaded what little bit of filament was left in the extruder. Then when I came in this morning, I was able to load up fresh filament, continue the print, and everything worked out just fine.
It worked.
Yeah.
Yeah.
That's the nice thing about the smart extruder.
Well, because a little visual indication where where it's been cold for several hours and where the print takes up again, but it's nothing.
Well, it's like our Rep2s right now. We just cold paused them for the podcast, and now I'll go back and they'll reheat up and go. It's the same, pretty much the same thing.
Just more automated.
Well, yeah, this it'll detect it, because otherwise, if it wouldn't have detected it and paused the print automatically, I would have been out. I mean, I would have been out probably 12 hours worth of printing and probably 150 grams, if not more, of filament. And I mean, when you're talking, almost $50 for a spool, it's not insignificant anymore.
No. But so, anything else we want to talk about on the Z18?
Other than your thing,
other than my next thing, other than my heat
I can't think
so
of anything.
I'll be putting the designs for the spool holder up on Thingiverse. I'm shocked at the lack of spool holders on Thingiverse, like overhead.
You guys designed this one?
He did.
Yeah, so I did.
And what did you design it with?
I designed this in Autodesk Fusion 360. I'm trying to learn. I'm more of a SketchUp person, but I'm trying to learn more Autodesk products, because the Autodesk products they just work better for doing this kind of stuff. So I'm getting used to a new interface, but it was a fairly simple part to design. Good learning project. So, yeah. But I think that you're right. That takes care of it.
I did have one thing to mention. When I always just, if I get burned out on working on a video, I'll come and just watch stuff print for a couple minutes, and it was doing a square infill.
Oh yeah.
Instead of a honeycomb like the typical MakerBot.
And what was your thoughts on that, John?
The reason that it does that, I was printing at low quality mode, and when it's creating an infill pattern that's rectilinear, it's just a straight grid pattern versus what it normally creates, which is a honeycomb pattern. The honeycomb pattern is stronger, but it takes more time to print. And I think I don't know if it uses more material or not. It's probably about the same amount of material total, but it does take longer to print the honeycomb infill than the rectilinear. Especially on a larger part.
It's just a preset that you could change that if you wanted, right?
I'd have to create a custom profile and put it in there.
Is that because of the new update?
No, it's no. I mean, we've just never printed any stuff at low quality.
I feel like I have, but maybe I just didn't notice or something. But,
no, I mean, almost everything that we print is at standard quality.
First time I've seen it, other than like with Lulzbot, I know the slicing software we use for that is always a square infill.
Right.
So I was just like, oh, maybe slice it differently, but
no. I mean, it was the default low setting, and yeah, I mean it cranks out prints really fast, and I'm actually surprised at how good the surface finish is for it being low quality.
If you compare it to a Rep2 print,
that was on regular quality.
Yeah.
Yeah.
So yeah, I mean
overall,
we're very satisfied with the Z18, which is, I mean, it's been out for over 6 months now, and it's nice to be able to say, hey, this does work.
Yeah, and we back it. That's kind of that's something that we pride ourselves in as a company. I'm going to do a shameless plug here, but
on the Fargo 3D printing channel and the Fargo 3D printing show, we're going to be promoting Fargo 3D printing a little bit.
is that we stand behind what we sell. If we don't believe in something, we don't sell it. So Z18, the MakerBot 5th gen line, we didn't sell it for a while because we didn't believe in it. Right. Now we believe in it. Now we sell it. So it's something that we can say, hey, just because Todd, you want a Z18 and it's not working, and I say, oh, a Z18 is not for you because of this, you as a client is going to respect that a lot more. Right. And that's what we do is we say, you know what, this isn't working right now.
Rather than selling you something and putting you through 6 months of frustration while somebody else figures it out.
Yeah.
Right.
So, I mean, that's a big thing that we do. So, done with the plug. Gonna move on to the next topic. If anybody else have anything on the Z18?
No,
that's the last. That was one I almost forgot. So
let's get a little creepy.
Yeah. He's really warming up on this topic.
Okay, so heat creep is what we're going to talk about. I got a nifty little diagram here.
And again, if you're listening, this is
that's
where
fine.
you
Jake's the one.
Computer,
so he's texting back here.
Yep.
So
Jake, don't tell him.
Tell hi to everybody. So if you're listening to the podcast, this would be a great time to watch our YouTube channel, as we're going to talk the theory of heat creep. Again, this is what, like I said, it's a theory. This is what is going on inside the thermal barrier tube, the nozzle, and the heater block for most of the 3D printers, especially in my case here, the Replicator 2. So we have our thermal barrier tube up top, and then we have the nozzle on the bottom, and then the heater block is here in blue. So what's actually happening with heat creep? So with heat creep, your heat is right here.
Watch it.
Go for it. So the heat creep with the you want to grab me a marker actually?
Yeah.
I'm gonna continue.
Color preference?
What do you think would show up good?
I don't know. Is there
Do purple.
Purple.
Because I hate red. It doesn't show up good. I'm not a big fan of purple, but I know it shows up well. So let's say this is your heater cartridge and your thermistor is over there. Yes. So with your heater cartridge, what's happening is all your heat's coming into this area right here, and then it's dispersing out from there. So with metal, it obviously heat dissipates over the metal. I think that's the right term. What's happening is all your heat's coming up here and going down here, and that's how you're able to melt something. So when this filament is coming through here, what happens as it starts to heat up, it actually swells. The plastic will swell up, and then in here is where it starts to become, it melts, becomes molten, and gets shot out. Now, when you're going to cool down your extruder, so what happens is you're like, all right, I'm done for the day, print's done. Whenever this is cooling down, what's happening is the heat is actually coming up here and creeping up the thermal barrier tube. It's called heat creep. And to counteract this, we've had the thermal barrier tubes, that's why they have the notch in it, so that there's less material, so that the heat doesn't get up there as easily. And also the threads kind of act as a little bit of a heat sink. So what's happening is there's this little notch in the bottom part of the thermal barrier tube. It's probably hard to see on the video, but the thermal barrier tubes actually have two different diameters. There's a larger bottom diameter and a smaller overall diameter, inner diameter. So what's happening is when the heat's going up here, what's happening is that PLA is starting to swell up where this is actually smaller. And when it swells, it sticks to the walls easier because down here we've compensated, and they've compensated for the PLA actually swelling. Where here, when the heat comes up here, this will swell, stick to the walls. That's why you get a barrier tube clog. Same thing happens in the 5th gen. Heat comes up, expands out, sticks to the walls, and then you can't get it out. And there's really no necessary way to compensate for that, except for maybe taking more material out. One way is to always unload your filament when you're done with a print, and another way to do it is actually to load your filament to unload. So what that does is right here where this notch is, this is all swollen plastic in here, so this is a thicker diameter. And when you if you just go and you hit unload on any of your stuff, even the 5th gens and the Z18s, if you go to hit unload, what's happening is this blob of plastic is trying to shoot up a smaller diameter. So this could break off. It might not come out at all. And when you just do the unload script, yes, it heats this, but it doesn't heat it as much as if you were to heat this, push the filament down, and pull it out. So that's what we recommend when you're unloading the filament. Load it to unload it. You load it because then you get that solid stream of plastic. This is all molten in here, and then you push down on that on the spring load, spring assist, whatever you want to call it. Push on that, and then you push your filament down, pull it out, clip it, and you're good to go. So because otherwise this mass could get stuck somewhere up the tube. So that's heat creep. So the heat is creeping up the thermal barrier tube. As it creeps up, it's going to cause the plastic to swell. The swelling is going to stick to the wall. You're going to get a thermal barrier tube clog. A couple ways to replace that, or you can replace it. You can try and get it out. It's easier just to replace it in the Rep 2s. 5th gens, it's kind of a pain, but you can unclog it, which we have a video on that. Trying to think of one other thing that I was going to cover with this. Oh, so when it's cooling down, that's what I was going to cover. So when the actual filament is cooling down, you're done for the day. You leave all this plastic in there. You walk away. It's cooling down, and it's creeping up the top. What's happening is it's also following the filament because it's acting as I don't know the proper term. Sorry, but it's acting as a piece to bring the heat up as well. So as the heat crawls up farther, and it swells up here, it swells up farther, and you go back and you go to preheat. What happens is the heat's not going to get all the way back up here because it's too far, because the mass just doesn't heat it that far up. It's not meant to. So that's another reason why you get some of the barrier tube clogs that you can't get out. It's because the heat went so far up that you're never going to get back up there. So I hope that helps. Explaining this, I got nothing else on that. So that's a heat creep 101. So done texting?
I learned a lot. I know I learned a lot.
Thanks. Trying to think of a cheesy 1990s thing, but I can't think of it. It's been a Monday.
But Jake, it's Friday.
I know, right?
And that's how you
Great.
deal
There
with
goes
heat
the
creep.
fourth wall.
Yeah. Yeah, that fourth wall was built up real high.
Oh yeah.
I know
wasn't-
a few
So
times
just
we pretend
stare,
it was Friday.
stare into the camera.
It was.
know you're
we
out there.
pretend it was Friday.
Yeah.
Like talking about that thing that we're doing tomorrow, Saturday.
Yeah.
And I was just like, oh man, it was just.
Well, I think we mentioned a couple times that we record this on a Monday.
Well, yeah, and then we a couple times and we're like, okay, whatever. Like it's definitely Monday. It's gonna come about 4 days from now.
Right.
Yeah.
That's what's up.
But I mean, and then we should have some exciting things on the Rep 2X side that I can't talk about, but we're going to release something later this week.
But they're exciting.
This week or next week? I don't know. I'll release it sometime.
Next week.
It depends on when stuff gets made.
Yeah. So it'll probably be next week.
Soon.
So look for it next week. We'll announce it. Should be an exciting piece. So
Yeah.
what
Well,
else
and then
we got?
another exciting piece. Todd is now with us full time. Normally, when Todd when you'd see him come onto the podcast, that was when he was leaving his other job and would just be showing up here. So now, instead of having Todd show up halfway through the podcast,
I'm here at the beginning.
yes. So we're very excited to have Todd with us. He's going to be helping us out with quite a few of the new projects we're working on. Just generally helping us out. Jake and I and everyone else on the team, we tend to get a little overwhelmed with things from time to time, just a
There's
little
a
bit.
lot going on here.
Yeah. So having another
Keeping
set
up
of
with the customers has been a
Yeah.
challenge.
yeah,
I
it's a
mean,
fun
you guys are
challenge.
Running us ragged. So keep doing it.
Yeah, keep it up.
Because Todd actually ships out all of our orders, so he does all the shipping, he does all the prep work for everything. So yeah, any of the orders you guys get, Todd's put them together. So
So one of
Those
the
are my
other
fingerprints.
things we were going to talk about, if you are listening to this on Friday, then tomorrow is Valentine's Day. So if you have
Get printing if you're going to.
yeah, if you haven't, there's still
your heart.
You guys don't know what I did yesterday. I just ruined Valentine's Day for everybody.
Yeah.
We'll talk about it after the podcast.
Yeah.
Oh.
So there is still time if you're listening to this to
You
get
can reprint
some
it. It only
gifts
took
printed.
40 minutes.
Yeah.
To reprint the heart that
It might have been
just
30. It
broke.
wasn't-
Well, and with only 30 or 40 minutes, you can print a dozen of
Okay,
these.
so
You
this
print them all for your mistresses.
all your Valentines.
This
all
is,
your
yeah,
mistresses.
this is a Mobius heart, and now it's just a little bit more complicated.
Well, it's like the open heart thing from K Jewelers.
Oh, yeah.
So look at that. Look at
the Open Hearts collection.
So it's a Mobius strip. If you,
They've been selling for the last 10 years.
if you don't know what a Mobius strip is, it's a one-sided object. It's pretty much you take like a ring, you cut it in one spot, and then you flip it. So you kind of follow. You can follow it with a pen, and you're not gonna stop. You're not gonna hit your pen line again.
Yep.
I mean, I guess you will, but it's really weird.
It's like a continuous plane that keeps.
Yeah,
Well, not
yeah.
continuous plane, but.
It's a
I got
infinite loop.
nothing.
So this is one of the things, and then the other thing is this 3D printed rose, which is pretty
the petals
cool.
fell off.
Yeah.
Yeah,
So
Are we going to put that up? I don't know.
yeah, the rose. We're not going to talk about the other project it's being used for
No,
yet.
but
I think we already did actually, but
Did we? I don't know.
we'll pretend that we didn't say that.
We don't know what we're talking about.
Yeah.
Well, I had to watch
That's
the
why you're listening
podcast
to
again.
us.
It's for Todd. It's for Todd's wife. It's actually we printed one for. Oh yeah, we can't say who
Oh,
else.
yeah, we don't want to
printed
ruin
for, 'cause
the
I don't-
surprise.
No, we don't.
So I for another project that I guess we mentioned before, but if you forgot, then you'll
Then
find out again later.
You'll have to watch another podcast. You'll find out next week.
I designed this in 3D Studio Max 2011,
I know it was last
which
week.
doesn't really matter. We talked about it, but I got it working. The stem is now printed. I had trouble because I was trying to print this as one piece, and I had to like chop it in the program. It's not perfect. We might like clean that up with a soldering iron or something. So I had like a fitted piece. There's actually a program called Coat 3D or 3D Coat. I can't remember, but it does that kind of stuff for you. I just kind of eyeballed it and hoped it would work, and it was good enough. But then, yeah, we printed this in the clear.
Translucent.
Translucent red. And the honeycomb actually looks really cool. It looks like veins. So, I mean, it kind of was just an added bonus,
Are we
I
going
guess.
to put that on Thingiverse? I don't know. It's up to you. I guess. It's your thing.
We could. I mean, it's not perfect. There are probably better roses on Thingiverse, but it was a good...
I don't think so. We looked.
No, there isn't one that
like,
has a nice
I
stem.
looked today, and there was a lot better
Well,
stuff.
Eric, we're leaving it up to you because it's yours.
Yep.
Okay,
It's your
I'll
design.
think about
I
it.
think this is
Someone's here.
What would that be?
I think this is part of the next week's announcement.
Oh,
I
okay.
think. So I'll have to go see. All right.
Go see.
I'm going to go where
All
it
right,
is.
We're losing Jake.
I'll go reframe that quick.
So-
while you.
So it's not out of balance?
Oh, he'll be back up in
be
a
back.
second. I'll put something
just gonna
funny. I'll put something funny there.
We just put some elevator music in here while we wait for Jake to come back.
I do have a video of this. I could probably put that up there too, of when it's like failing. It was just really awful to watch because it was all good until about here. Then it would get up to here, and then it would start pushing and catching friction, and apparently it knocked over one time when I wasn't watching it. So this is probably the fourth stem I printed because the other ones were not working. Because I have a fitted little peg on the top with this as well, and it just wasn't happening. So this was the best I could do.
Oh, it turned out really nice.
No, I'm pretty happy with it. I haven't done 3D in a while, so maybe I'll keep working on it. Get some other cool stuff.
Recreating those organic
It's
shapes
it's
like
hard.
flower petals and stuff is really difficult.
It's not going to happen in CAD. So
Sorry.
Jake, you're literally the worst.
Yeah. What did I miss? Sorry. New product stuff that were coming.
Oh, well, that's
Yay.
that probably gonna get cut out. Part of it.
I don't know. I'll have to see how boring it looked.
Sorry.
All right. So that's Valentine's Day stuff.
I mean, there's going to be like with the chocolate printers. I mean, it's an application that they're not really like available yet, like in a big way. But
I mean, a year from now, it's still going to be a novelty.
Yeah.
I know with 3D Systems, when they're talking about the Coco Jet, it sounds like maybe sometime in 2016. And given 3D Systems' track record, I'd count on it for Valentine's Day 2017. Yeah.
2030.
Yeah. Well, hopefully not.
Full-size chocolate figure.
But I think that. So did we mention 100 subscribers?
We did not. We hit 100 subscribers.
I think we're at 110 right now. Which
I had a funny thing. YouTube has little tricks and tips about good management. Oh, I just took that photo of you. I'll put that up. Maybe it was kind of funny. Yeah.
Creep.
It said
Yeah.
when we hit 100. I think we hit 100 subscribers last week at some point. Like we had a couple videos, Lulzbot and the Lulzbot.
Extruder clog?
It was the extruder clog for MakerBot, and then it was the Lulzbot unboxing. Lulzbot Mini, sorry. They got us quite a few views. And we got, those were pushed on a couple of websites, so that was really nice.
Thanks for 3dprint.com for the unclogged video.
Yes.
And thank Lulzbot for the unboxing video.
Yeah, that's on their official Lulzbot product page, so very cool. But it got us a lot of attention, at least, to get us over 100 subscribers. But it says, you're getting pretty popular, ! If your fans got together, they'd fill up a whole movie theater.
Whoa.
Check out your subscribers and keep it up.
How big is this movie theater?
Yeah. I don't know.
Like the Safari?
The Safari.
Yeah. Is it like a
IMAX
Fargo?
types,
Well, even a
or-
Fargo movie theater, you can fit 100 people in.
Well, it's probably
yeah,
like
you could.
250. They
No,
have,
I
they
mean-
have the small
I mean,
screen
sorry.
Fargo Theater.
You could fit 100 people in it, but
Not
it would
fill
still
it.
be, yeah.
Yeah.
They have the B screen, which
yeah,
is like
the second
88
screen.
seats or something.
Yeah.
So-
Go there, we'd have 100 people.
Hey, you could put 100 people in a place where 100 people would fit. It'd be great.
You could fit them in an elevator.
So I think we weren't sure if we are going to mention this or not, but since the magazine's sitting right there, so this is, what's the name of this magazine again? New Ground. There's a 2-page article in here about how 3D printing is going to be impacting the agriculture market. Just talking about how 3D printing is, it's already been changing things from for equipment manufacturers, helping them come up with new designs. But one of the other things that gets talked about in here is how farmers, if they have a part breakdown, for farmers, if they have a piece of equipment breakdown, it's kind of a big deal, because if they lose a day of productivity when the weather's good and the conditions are right, it's difficult to put a cost on there. But if you can 3D print a replacement part, even if it's just a temporary replacement part until the full-blown part can be delivered, I'm so distracted. Then that's going to be a big deal for farmers. And then in the future, when metal 3D printing becomes more inexpensive and you have more of the part files available, you're going to have either your dealerships start being able to print parts, or even some of the bigger industrial farms are going to be able to print parts on demand.
So eliminate some of the shipping time and
manufacturing
issues.
And that doesn't mean that parts are going to start being 3D printed and those are going to be the final parts, but it'll at least get that farmer going for the next 2 to 3 days until the official part can show up, and then they make the replacement of that full part.
Yeah, and I'm actually going down to Phoenix in 2 weeks, 3 weeks, to talk at the 2015 Egg Commodity Classic in Phoenix, Arizona. Going to be showing off a Rep 2, so yeah, we're going to be talking about how 3D printing, or I'm going to be talking about how 3D printing is impacting the farm community, the farming community and egg in general, because there's a couple different ways. The one way John mentioned it, and the other way is actually using corn in the materials. PLA is derived from corn. So it's kind of interesting how farming plays
life.
Yeah, it plays a huge role in 3D printing, believe it or not. So so that was cool.
I think that's it, though, for this week. Yeah. So on behalf of Jake, myself, Eric, and Todd, thanks for watching and listening. And if you haven't already, subscribe to us on iTunes, YouTube, follow us on Facebook, Twitter, pretty much any social media network. We're on it in some way, shape, or form.
Everywhere.
So, again, on behalf of all of us, thanks for watching.
Thanks.
Oh, man.
John's going to sleep through this podcast.
Oh, if you didn't hear that, he just hit his knee. Oh,
Cling, man. There's your...
That's probably that was a clap right there.
So what's the...